Hi Math 1, this is Miss V, and this is your 3.6 video for Ready, Set, Go. Excuse me. Before I start to do problem number 1, I want to talk a little bit about what we're doing here when we do this kind of mess of algebra. If you take a look, we have two functions. One of them is called f of x and the other is called g of x. And we've been working with multiple functions on the same coordinate plane for a while. And if I were to look at these when they're graphed, what I would see is I would see a function that kind of looks like that, and then a function that looks like that. And I'm just kind of guesstimating what these are going to look like. But they would eventually intersect. And when they would intersect at a point where the x value and the y value were the same. And I'm making these numbers up, but we could pretend that x is 5 and y is -3. And what we'll notice is there's a point on f of x and a point on g of x that has the very same x value and the very same y value. So let's take a look at the equations and get some real numbers, because those were just kind of hypothetical numbers. If we look at f of x, what we'll notice is we can substitute y for the f of x part, because we've acknowledged that saying f of x is the same thing as saying y. And I can do that here for g of x as well. And we just said that they will intersect somewhere, and if we're looking for the intersection of those two functions, we're looking for the place where y is the same for both of them. This y value, whatever it is, I don't think it's -3. I will be shocked if it is. It will be a big coincidence. But this y right here is going to be the same y value as this y right here. And since they're the same thing, I can take one of them out, and I'm actually physically going to erase that y, and I'm going to put in 5x plus 12. I did a little thing called a substitution. Since I know y is the same as -5x, and that should be a negative. Since I know that y is the same as -5x plus 12, I'm going to take out the y and put in the -5x plus 12. They're equal. So notice what I have now. -5x plus 12 is equal to -2x minus 3. And you guys have been solving equations like this all year long. So let's find out what x is. I think I'm going to add 5x to both sides. I think that's going to be my strategy to start. And then I'm going to add 3 to both sides. And then I'm going to solve for x, and I get x is equal to 5. Oh, how bizarre. Look at the x value that I arbitrarily chose here. That was pretty funny. If the y ends up being -3, I'll fall over. So I know what x is now, right? I know that's my x value, that they intersect when x is equal to 5. What I don't know is what the y value is. So I'm going to go up into one of these equations, and I'm going to put in f of -5, or +5, excuse me. F of +5. In other words, when x is 5, what is y? And that should be equal to -5 times 5 plus 12. So let's go ahead and solve this, and we'll find out what y is, right? And I'm going to scoot this all over here because I don't think you can see what I'm writing. We decided that x was 5, so I want to find out what is y when x is 5 in this equation. And let's see, this would be -25 plus 12, and that would give me a y value of -13. So if I go back to my hypothetical, I was kind of close. When x is -5, y is going to be -13. And you guys can graph these. I would graph f of x in y1 and g of x in y2. And you'll see this point on the graph. And if you go to your table, you should find that for both equations, you find an x value of 5 and a y value of -13. So try that, won't you? I'd like you to do number 2, 3, and 4 on your own. So it gives you 2 equations, and in each case they're lines. They graph like lines, and they're going to intersect somewhere on the coordinate plane, and it's your job to find the x and the y value where they intersect. Give that a try, and we'll talk about it in class. Let's see if we need to look at any of the set and go instructions. The set says, here's f of x. Find these values. And so this is kind of like 3.5. It's saying when x is 4, give me y. So we're going to go over to an x value of 4, 1, 2, 3, 4, and we're going to find that y is 1. This is saying when f of x is 7, in other words, when y is 7, what is x? So I'm going to go up to a y of 7. And that's really kind of sort of off the graph a little bit, isn't it? That's where a y value of 7 would be. And it looks like we might be at x value of -4 maybe. That's as close as I can tell from really extending that line all the way up to a 7. So this is just simply asking you to look at these graphs, and if it's asking you what is y when x is a number, finding that, or what is x when y is some number, finding that as well using the graph. Give that a try. We'll talk about it for a little bit. So in this case, we've been doing these this is the go portion, or is this still the set portion of 3.6? Oh, here's the go portion. It's asking us to describe the function and talk about intervals of increasing, decreasing, minimums, maximums, domains, and ranges. And we have been doing this a lot in class. I'd like you to do the go portion on your own, and let's discuss that in class. That's your video for 3.6. Thanks, Math 1.